All right, everyone, this is your last quick reminders, broad scopes, tips, things to watch out for, things not to forget, all that kind of stuff. Nothing too specific, just some general things to keep in mind and remember. So we're going to start by talking about limits. Remember, for a limit as x approaches infinity, that's what happens as x gets really, really big, or negative infinity. Really, really big, but negative. So that's a race usually between the top and the bottom. If the bottom wins, then the limit is 0, for example. Definition of derivative. Don't forget about this structure. This is a derivative question in disguise. It's got our slope, structure, change in y over change in x, and especially if it has that limit as h approaches 0. If there's a number here instead of x, take the derivative, plug in the number. If there is just the f of x, then it wants the derivative of whatever this function is. L'Hopital's rule, you guys liked using that? If you're going to use L'Hopital's rule, make sure you're checking that the top is 0 and the bottom is 0. You want to check them separately so that we get this 0 over 0. Then we can say that the limit of the function should equal the limit of derivative of the top over derivative of the bottom. And finally, continuous. Continuous means that the limit of the function equals the value of the function. They like to throw this on multiple choice. So for example, if instead of filling in the circle here, the green points were where f was, well then the value of f would not equal where the limit is going to. So that's what determines whether it's continuous. If it's a piecewise, plug in the top, plug in the bottom of the piecewise, see if they match. On to derivatives. You've got your flashcards for derivative rules. So if you're hazy on any of those inverse trig or logs or anything like that, make sure you look at those. Any question about tangent line? Find the slope of the tangent line. Find where the tangent line is horizontal or vertical. Horizontal is where it's 0. Vertical is where it does not exist. Any of those, if it asks about tangent lines, we're asking a derivative question. Point slope form for equation of the tangent line, and the derivative goes in your slope because derivative tells you slope. X in a square root or cube root becomes a fraction. X in the denominator becomes a negative exponent. So square root of x is x to the 1/2. 1 over x squared is x to the negative second. So make sure you don't mix those up. More derivative stuff. Mean value theorem. This is also average rate of change. So if it asks for average rate of change or average value of the derivative, then f of b minus f of a over b minus a. And it guarantees a value for the derivative versus intermediate value theorem, which is about the original function. And it needs you to be continuous and differentiable. So if it asks, is there a value guarantee where f prime is a certain number? That's a mean value theorem question. Maximum and minimum, this can come up a lot of different ways, but the steps are always the same. Set derivative equal to 0. A lot of times you get a point just for setting the derivative equal to 0, so make sure you do it. And then changing from positive to negative for maximum, negative to positive for minimum. And then you're going to compare it with the endpoints if it's on a closed interval. So you want to compare those, whatever points you found, with your endpoints, see which one's the largest or see which one's the smallest. Finally, for related rates, if you come to related rates, take it a step at a time. It's a lot thrown at you, but write down the information that you have, write down whatever formula you're using, area, volume, Pythagorean theorem, whatever it is. And then once you get to that derivative step, then it's just a matter of plugging in all the values that you know. So a big part of it is picking apart the question. Make sure you write down what values you're being told, what value you're trying to solve for. On to integrals. Remember, integrals tell you area. For Riemann sums, overestimate or underestimate is determined by increasing or decreasing. If you're not sure, draw a picture. That's versus tangent lines, that's determined by concave up and concave down. But for Riemann sums, your explanation should involve increasing and decreasing. Trapezoid. Here's your formula for area of a trapezoid. The h is going to be your x distance between the x coordinates. Base 1 and base 2 are the two y coordinates. 1 over x involves natural log. Other exponents don't. So 1 over x, that's natural log. 1 over x plus 2, natural log. 1 over 2x, natural log. 1 over x squared, not a natural log. 1 over x to the 3 halves, not a natural log. If it involves another exponent, then it's some other derivative rule, probably one involving exponents. If you do use substitution, make sure to change the bounds. You want to switch, now that you're in terms of u, the bounds should be in terms of u as well. Plug in for x, figure out what u should be. Those are your new bounds. Average value of a function, make sure this is one that you should absolutely just know. 1 over b minus a times the integral from a to b. Remember, that's as opposed to average rate of change, which is f of b minus f of a over b minus a. And then for separation of variables, make sure you recognize when that question happens. Particular solution. It gives you dy dx. It asks for the original function. Separation of variables. Separate out the variables. Take antiderivatives. Make sure you have your plus c. At that point, even before it gets to the more complicated nitty-gritty details, that's the majority of the points of those kind of questions. So make sure you get those easy points. Position, velocity, acceleration question. Total distance traveled. This should be a free point right here if it's given to you. Either if it has this integral or asking you to find the total distance traveled. Integral, the absolute value of velocity, is total distance traveled. Speeding up or slowing down, check your velocity and acceleration. Velocity and acceleration have the same sign. It's moving the same way it's being pushed, speeding up. Velocity and acceleration have different signs. It's pushing the opposite direction that it's moving, slowing down. And pick apart on any question. Try and pick out, is it a position question, a velocity question, or acceleration question? A lot of times it'll just say find the position, but sometimes it'll say something like, when are we moving to the left? Oh, that's a velocity question. That's when is velocity negative. Graph questions. If you got a graph question, make sure that when you give your explanations, explain it in terms of the graph they give you. So if they give you f prime, your explanation should involve f prime in some way. If they give you that g is the integral of f, then the derivative of f is g, and you should say that at some point in your explanations. They'll be looking for it. If you want derivative, use your slope. Integral, use your area. Pay attention to what counts as negative and what bounds need to be switched. If you find your integral from 2 to 0, change it from 0 to 2, switch your signs. Areas under the x-axis should count as negative. But derivatives, you're looking at the slope of the graph. If you want the integral of the graph or antiderivative of the graph, use areas. And just a general word of advice, if you're asked to explain something, then explain what you're looking for first, then look at the graph. So if you're looking for when f is increasing, then write down f is increasing where f prime is positive. And then look at the graph and find where it's positive. Think about the calculus first, get the calculus out of the way before you start looking at the graph. Okay, and some final general reminders. If it asks you using correct units, make sure you include the units. If it asks you explain something using the units, or be sure to include units in your answer, then make sure you put the units. They'll be looking for that to give you points. Make sure your calculator's in radian mode. Keep track of initial conditions. Initial conditions will go in the lower bound of the integral. So if it tells you that a of 2 is 3 and then gives you a rate, if it gives you a prime, then your function should look like this. 3 should be your starting condition, your starting place, and then your integral should go from 2 to wherever you're going. Because we are starting at 2, so that if I plug in 2, this integral turns out to be 0. And then I'm just left with the value being 3. So put that starting condition there and put the x value as the lower bound of that integral. 2012 multiple choice practice. Remember, I have a video. I'll put it in the little card up at the top right. Ooh, fancy. I don't get to use that very often. Little card in the top right, that has the practice multiple choice. If you want some more detail, if you want me going question by question through practice multiple choice, then that resource is there for you. I just want to remind you that that's there. And finally, don't get intimidated if a problem looks complicated, especially on the free response. They often like to throw in an intimidating looking question. Don't let it throw you. Just roll with the function that you're being given. Roll with whatever complicated expression they're telling you to try and intimidate you. Because a lot of times it ends up simplifying. Things end up canceling, and it ends up looking a lot simpler, being a lot simpler than it first looks. So don't get intimidated by those kind of questions. And anything else I want to remind you not to forget? Oh yeah, you shouldn't forget the chain rule on any derivative question, of course. All right. Finally, I want to say thank you for all the work and time that you've been putting in throughout this entire year. I've really appreciated it, and I'm wishing you all the success, and I'm hoping that that work that you've put in and time that you've put in pays off on your AP test. So best of luck to you all, and I will talk to you all soon.